4.5 billion years ago, a space rock formed out of a mixture of dust and gas around the young sun. That space rock that I am talking about is Earth.
It grew larger thanks to countless collisions between dust particles, asteroids, and other growing planets. A lot has happened since the Earth became suitable for life.
In today's episode, we will be presenting some videos that explain the Earth's materials and processes regarding the identification of rock-forming minerals using their chemical and physical properties, different types of rocks, types of stress that occurs on rocks result and evidence of the continental drift theory, index fossils in geologic timescale.
Good day, Sir Jovan. Thanks for accepting our request. It would be an honor to talk with you.
Likewise,
We have some questions prepared for you. I hope you are prepared.
please be my guest.
How can you define rocks by their properties?
Here's how you can distinguish a rock by its physical properties. You can distinguish a rock physically by its color, appearance, transparency, and hardness.
So color is how the mineral or rock reflects in my eyes. Appearance is like basing the texture of other things. Transparency is like can you see it through or not. And hardness, which explains the word itself, is how hard it is. Did I elaborate it right?
Precisely. Now that we are done with physical properties, let's go to chemical properties. These intersection on chemical properties are a bit complicated, but I will make them easier to understand. You can identify the chemical properties of a rock or mineral by its chemical classification, chemical composition, and crystal system.
Can you explain those three properties?
Why not? Just remember that chemical classification is based on how the structure of its element is aligned to make the mineral or rock in its chemical composition. It's the chemical formula or two or more elements that make up the mineral or rock.
Wait, did I hear this right? Chemical classification and composition are basically the same, but the classification is how the elements are aligned to make up a mineral or rock.
The crystal system of a mineral or rock is how the atoms, ions, and molecules are arranged in a set order that makes up its crystal system.
Thank you for your cooperation, Sir Jovan.
Igneous, metamorphic, sedimentary, and stratified rocks are some types of rocks that we will talk about. Isn't it fascinating to know that there is a rock that's older than the first humans? Our world is surely filled with surprises for us to discover. Class, did you know that igneous rocks are the rocks in the rock cycle without any organic remains?
Prof, I can comprehend what you just said. Can you elaborate it more?
Igneous rocks do not have any organic remains because they are formed when a hot molten rock crystallizes and solidifies.
That's more like it, Prof. Can you tell us more about other types of rocks?
Alright then, let's proceed to metamorphic rocks. Metamorphic rocks are formed through the transformation of pre-existing rocks in a process called metamorphism.
Metamorphism? What's that?
Metamorphism, meaning change in form, means that the original rock is subjected to heat and pressure, which cause physical, chemical, and mineralogical changes to the rock. And as a result, it will be a metamorphic rock.
Okay, I understand now. But what about sedimentary rock?
Good question. Sedimentary rocks are formed from deposits of pre-existing rocks on pieces of once-living organisms that accumulate on the Earth's surface.
Other rocks that we will talk about, other than igneous, metamorphic, and sedimentary rocks?
There are more types of rocks, but we will only tackle these three types in today's class. But I do have one more topic prepared for everyone. Do you all want to hear it?
Yes!
If you all want to hear it badly, the one more thing I'm talking about is stratified rocks. These rocks are formed by wind, rain, and glacial formations. It is also the most common rock found near the Earth's surface.
What are they composed of?
Stratified rocks are largely composed of fragments of other rocks. For this reason, they are sometimes called fragmental rocks.
So like in the desert, those layers in the sandstone are like stratified rocks?
Precisely. Now let's talk about those two methods for identifying the stratified rock. The methods are absolute or radiometric dating and relative dating.
What are those types of dating you're talking about?
Absolute or radiometric dating is a method used to determine how old the rock is by its radioactive decay.
What does that mean, Prof?
It means that a radioactive isotope in the rock decays into a stable isotope. The decay occurs at a predictable rate, so the age of the sample could be determined.
But what about the other method?
Relative dating determines which things are older or younger based on their relationships.
So, absolute dating is measuring how decayed the rocks are by the radioactive isotopes.
Precisely. Now that I am done talking about these types of rock, class, are there any questions regarding our topic?
Breaking news! Just now, an earthquake with a magnitude of 8.5 just hit Epic School Lipa. We have some witnesses in different parts of the school. Jovan? Jovan, are you there?
Yes, Stan. I'm on the south side of the school, and I have someone here who witnessed the phenomenon.
Miss, can you tell me what happened?
I was filming a TikTok video when the ground shook and the earthquake caused part of the cement floor to rise in the restricted area.
My witness here said that a part of the ground has risen. Back to you, Stan.
Thank you, Jovan. Those phenomena are just hard to explain, so that's why we have an expert on the line. Geologist Aaron Barrion is on the line. Sir, are you there?
Yes, I'm here.
Sir Aaron, can you explain the phenomenon that our witnessed in the school?
The victim witnessed a phenomenon called converging tectonic plates or compression stress. This phenomenon means that there must be two separate tectonic plates. That's why the cement grows. The tectonic plate on the cement has a lighter mass than the other tectonic plate. That's why the other tectonic plate subducted and made a ramp to direct the other plate to go up.
Thank you, Sir Aaron, for that wonderful explanation. We have another victim of the earthquake on the north side of the school. Ian. Ian, are you there?
Yes, Stan. I have a victim here who witnessed the making of a big trench on the ground. Sir, what happened?
I was taking a picture of the flower and the earthquake happened.
Stan, the victim here said that he was taking a picture of a flower and then the earthquake happened. Back to you, Stan.
Thank you, Ian. Ian said the ground split and made a big trench. That's a coincidence since the first victim we interviewed said the part of the land has risen. Sir Aaron, the victims we interviewed said the ground made a big trench. Is that connected to the first case?
Yes, because when the first case is happening, two plates push each other, which means that the other side of the plate must be stretched out. This phenomenon is called diverging tectonic plates, or tension stress. In this case, the tectonic plates had been pulled apart so hard that they made a hole in the ground.
Thank you, Sir Aaron, for that. Wait, I've been told that we have another victim who witnessed another phenomenon. Prince? Prince, are you there?
Yes, Stan. I am on the west side of the school.
What happened there?
I have a person here who witnessed another phenomenon. Sir, what happened?
When I came up from the bathroom, I felt sudden shake, and after that, the wall of the bathroom was misaligned and made a hole in the bathroom.
You said misaligned? What do you mean by that?
Like the wall was misplaced by like a meter ahead. It's like the ground shifted forward.
Stan, this witness said the ground shifted forward. Back to you, Stan.
Ground shifting? That's a new one. I've never heard that one before. Sir Aaron, can you explain why our victim said the ground shifted?
This phenomenon is commonly called transform tectonic plates or shear stress. The victim witnessed the ground shearing. This means that the ground is moving sideways, but there is always contact between these tectonic plates.
Thank you again, Sir Aaron, for your explanations. Those were the news stories for today. See you again on APEC News.
What's up?
Have you two prepared for the upcoming exam?
Yeah.
What? Do you know the results and evidence of the continental drift theory?
No. How about you, Pins?
Me neither.
Okay guys, I will explain it to you thoroughly. A scientist named Alfred Wegener discovered the continental drift theory, which states that the Earth had one supercontinent called Pangaea around 225 million years ago.
How can we know that is true? Can you give me more evidence of the continental drift theory?
Absolutely. The scientist Alfred Wegener came up with this idea because he noticed that the coast of Western Africa and Eastern South America look like puzzle pieces.
Oh, that's why the theory is named continental drift theory, because the continents are drifting apart.
Not just the random movements of plates, it's actually diverging from one another. That's why it spread apart and formed a lot of underwater volcanoes. Because of the tension stress, the crust widens and thins, and polycid volcanoes begin to form in and around the area. The widening crust along the boundary may become so thin that the piece of the continent can break up to form a new tectonic plate. Now that you understand Alfred Wegener's theory, let's go now and we'll be late.
Good day everyone, my name is Prince Ehrn and I will be your tour guide for today. Welcome to Museum of Ape. In this exhibit, we will learn about index fossils and geologic timescales. Are you guys ready to learn?
Ready!
First things first, does anyone know what index fossils are?
Is it like those colorful rocks can be found in the tropical seas?
Those are called coral, silly. Your answer was incorrect, but you have the idea.
I remember correctly, are index fossils those materials from animals or plants from thousands or million years ago?
Correct. Index fossils are animal or plant preserved in the rock record of the earth that spans a particular geologic time or environment.
So basically, index fossils are just like that preserved in a rock.
Precisely.
So why is the geologic timescale connected to the index fossils?
A geologist uses the geologic time scale to subdivide time, breaking it into usable, understandable segments.
So it's like how we humans subdivide time into usable units such as our calendar year, months, weeks, and days.
You are absolutely right. Index fossils are used to determine geologic time based on the existence of indicator species and mass extinction of index fossils record.
Those topics are just one of the few that are connected to Earth's materials and processes. We just explained the basic and easy topics so you can handle the harder topics coming in the future. My name is Jovan Igle.
My name is Aaron Jastin Barrion. My name is Tristan Xavier Cabiscuelas.
My name is Castillo.
And my name is Tristan.